Let's discuss the chain rule for derivatives. The chain rule is used when we need to find the derivative of a composite function. Some examples of composite functions are things like f of x equals sine of x cubed or g of x e raised to the power of 2x. These are functions that have an inner function and an outer function. Another way to recognize them is that you have a non-x expression like x cubed or sine of x where you would have expected to see just x.
There are three common ways to think about taking a derivative using chain rule. The first is verbally. In words, we could just say, take the derivative of the outside, leave the inside alone, and multiply by the derivative of the inside.
As an example, let's look at finding the derivative of sine of x cubed. Here we have sine of something as the outside function and x cubed as the inside function. The derivative of sine of something is cosine of something and we leave the x cubed alone. It's really important to do that. Then we multiply by the derivative of x cubed, which is 3 times x squared. Putting all the pieces together, we have of x is equal to cosine of x cubed times 3x squared, f prime. Another way to express the chain rule is using prime notation. If we have f of x is equal to g of h of x, then f prime of x is equal to g prime of h of x times h prime of x. Please notice that this is just the same thing we were saying before, with g of x as the outer function and h of x as inner function. Now let's look at how we would apply this pattern to find the derivative of f of x equals cosine of x to the fourth. Our pattern relies on knowing f of x in terms of g of x and h of x. We've put the outer function g in blue and the inner function h in red. We will use lighter versions of these same colors for the derivatives of these functions. The pieces we need for the pattern are g prime, h, and h prime. Since g is equal to cosine of something, the derivative g prime is equal to negative sine of something. We know that h is equal to the x to the fourth, so h prime is 4 times x cubed by the power rule for derivatives. Now we plug the pieces into the pattern to finish the problem. The final answer is f prime of x is equal to negative sine of x to the fourth times 4x cubed.
Let's look at another example and see how we could do this problem in two different ways. Here we consider the function w of x is equal to tangent of 2 raised to the x power. Again, we decompose the function into the outer function g and the inner function h. Here the outer function is tangent and the inner function is 2 to the x. Since g is tangent of something, the derivative g prime is secant squared of something. We also know that the derivative of 2 to the x is equal to the natural log of 2 times 2 to the x. So we found the pieces g prime, h, and h prime that we need for the chain rule pattern. Now we just plug them in where they go. Grime of h of x becomes secant squared of 2 to the x and h prime of x is natural log of 2 times 2 raised to the x power. The final answer is f prime of x is equal to secant squared of 2 to the x times natural log of 2 times 2 raised to the x power. Be careful. You might think that you could do something to simplify with this pair of 2 to the x terms, but that's not the case. The first 2 to the x is in the argument of secant squared, so it can't come out in play. We could do this problem without writing out all the g and h business if we just talk ourselves through it. Outer function is tangent, inner function is 2 to the x. Derivative of outside, don't touch the inside, is secant squared of 2 to the x. Derivative of the inside is natural log of 2 times 2 to the x. Multiply them together to get the final answer f prime of x.
While this answer is correct, we would usually rewrite it in a different way to avoid confusion. When we have a function with multiple pieces multiplied like this, it is more common to put constants in front, followed by power or exponential functions, followed by functions like trig functions that have parentheses around an argument. In this example, it would be more common to rewrite this function as natural log of 2 times 2 to the x times secant squared of 2 to the x. This has the advantage that there is less potential confusion about parentheses.